Okay. Good morning, good afternoon, good evening, wherever you are. Welcome. Yes, while people join, I'm gonna try and put some slides up. And hopefully you can see my slides. So hopefully you are where you thought you were going to be. This is a lightning session on learning a little bit more about the iSAQB Professional Software Architecture Qualification or Certification. And my name is Vincenzo Marchese. So we're going to give a minute for other people to join, and then we get going. In the meantime, I'm going to do some setting up. And then we're ready to go. Right, here we are. Welcome again. Thank you for joining. Today's session will explore a little bit about a certification for software architects. The organization that sets the curriculum and then awards the certification is the International Software Architecture Qualification Board. And my name is Vincenzo Marchese. I've been spending most of my professional life in architecture, starting from software architecture, integration architecture. You can see here some of the organization that I worked for, and eventually working my way in being the lead architect for some big digital transformation project. And eventually I moved into enterprise architecture, and when I was at UBS, I've established and led for 4 years the enterprise architecture team globally there. Then I spent a few years in management consulting, Boston Consulting Group, in the digital side of consulting. And for the past couple of years, I've set up Architectural Thinking as my boutique education and consulting company, specifically for architecture. I'm an accredited training provider for the International Software Architecture Qualification Board. And I operate from London, but I deliver training and consulting pretty much across the world. So that's me. And that's what we're here for today. So there's 3 broad topics. Obviously, the iSAQB curriculum for the certification is delivered over 3 full days of training. You can split that up. So the way I actually deliver is it through 6 half days training. But today we'll cover some of the topics that are in the curriculums. Obviously, we'll be together for half an hour, 45 minutes. So there's no time to even at a high level cover the whole curriculum, but I'll give you an idea of what are the important things that the curriculum covers. The first is about, some fundamentals. So establishing a common ground, so to speak. I'll talk a little bit about quality models, because that's one of the distinguishing feature or characteristics of iSAQB certification. Then we'll talk a little bit about what are the architecting approaches that are described and included in the iSAQB curriculum. And finally, I'll give you an overview of what the other topics are, just the list of topics that are covered in the curriculum. I'll talk a little bit about the certification, and also hopefully we'll have time to discuss a little bit on how it differs from other architecture certification that are available out there. For example, the one from the Open Group TOGAF, and how iSAQB is different from TOGAF, for example. So if we start with the first topic, architecture, software architecture specifically, a little bit of history. So the term itself comes from 2 Greek words, which is archi, chief, and tekton, builder. So the idea of the architect was he would be the chief builder. So I think over the years, particularly in the software industry, this has diverged a little bit. often one of the reasons why architects are criticized often is that they sit in the ivory tower. That's the metaphor that is used. But actually, the term architect, comes from being the chief builder. So as architects, we always need to be involved at whatever level we operate in the architecture, spectrum. We need to be involved and be aware of what's being built and be able and be part of the decision making on the building side. In terms of the softer side of the thing, so before the 60s, actually software wasn't that important. The important thing that was being developed, and there was a lot of research and industrial effort was on the hardware side of thing. But in 1958, when the integrated circuit was invented, that changed everything in a way because hardware became cheaper, more powerful, and eventually pretty much a commodity, although it isn't a commodity. And that meant that the software side of the equation started to become bigger and more complex. And with more complexity, came higher failure rates. And eventually that led in 1968 to what is considered a very pivotal moment in software engineering and architecture. So in this NATO conference, you can find the proceedings online. They're really interesting. But the term software engineering, so there was a realization that software engineering needs to be approached from systematically rather than on an ad hoc basis. So it had to become a proper discipline. The first concept of architecture emerged. When I do the full training course, I like to talk a little bit about the history side of architecture as well. We're not going to have time today, but you can see it on the right. When there are key concepts in the field of architecture, whether it is Conway's law or how do we get to architectural decision being one of the most important aspects, conceptual integrity, I always refer to those individuals and sometimes the papers and the books that actually were the origin of that concept. One of the things that I often refer to, for example, is Larry Constantine. I mean, nowadays it's very difficult to talk about architecture without talking about coupling and decoupling and dependencies. And, the person that actually originated the concept of cohesion and coupling was Larry Constantine. And I think it's really important to give credit. Some other Perry and Wolf, I'll talk a little bit about them in the definitions in the next slide. But it's always interesting to understand where some of the pivotal concepts in the field of architecture have emerged from and who were the originators. So on the definition side, obviously there isn't a single definition which is universally accepted to be the definition. So the way I think about it, most of these definitions are useful. None of them is complete and correct. And really it's up to us to see. But a couple of things that I would point out is, first, the ISO 42010. So this is what we actually study and learn and unpack in the training course. And of course talks about the elements and the relationship, but also, which to me is really, really interesting, the concept of the principle, the design, the evolution. So the big, in the past, people thought of architecting as a one-off exercise, the big design up front, and then all the decisions were made. That's an outdated concept anymore. And it's really important to understand not only when you design an architecture for the initial version 1 or the minimum viable product, but also have an idea of how that architecture is going to evolve over time. One of the other key concepts is actually, I mentioned this in the previous slide, in 1992, seminal paper by Perry and Wolf, where they actually said architecture is not only the elements and the forms or the structural side of things, but it's the rationale. So the why, we choose to architect a system in one way rather than another. The why, the rationale is really, really important in the way we actually communicate architecture. Some architectural definitions are less formal than others. I love this one from Martin Fowler, which is architecture is the important stuff, whatever that is. Grady Bush, this is really interesting because he was one of the Gang of Four. But what he now says is architecture represents the significant design decision that shape a system. So I think over the last maybe 10, 15 years, what we've seen is that the way architecture, software architecture, but not only software architecture, domain architecture, enterprise architecture, the way people think about these things is that they actually, although we produce blueprints and diagrams, the really fundamental concept around architecting is how those decisions are made, who makes them, how we document, and so on and so forth. In the course, I actually talk a little bit about what is architecture in a broader sense. So, I distinguish, for example, architecture as the abstractions. I distinguish that from the architecting, which is the methods, the framework, the behaviors, the techniques that we adopt, and then the design decision, which is the architecture. So again, impossible to cover in a few minutes, but I just want to give you a sense that there isn't a single definition, and actually you'll find the one that suits best what you're trying to communicate to your audience. And the other thing that we cover in the course is just to give you an idea of where we are, because the tasks of the architecting task go from ideation to actually maintaining the system. And in the training course, we cover to some degree, to some level of detail, this task. But today in this session, we will talk primarily about clarifying requirements and to some degree architectural decisions. But of course, the spectrum of tasks is much broader. And I talk about architecting tasks because it doesn't mean that all these tasks are actually performed by people that have an architect job title. I see architecting as a discipline that is performed by people in organizations, from the CIO to engineering and support engineers. So these are kind of roles rather than job titles that I'm talking about. Right, so architecting, a little bit of the history of architecting, and then we dive into the, how do we know when an architecture is a good architecture, or even better, when it's the best architecture? And this is one of the examples that I used during the training course. If I were to ask you out of these 4 options, what is the best architecture? Obviously, you wouldn't be able, nobody would be able to say is A, B, C, or D, because the question is, depends. Yes, but what does it depend on? So I could give you, okay, the functional purpose of the building is to store grain, up to 5 tons of grain, let's say. Okay, then you can already exclude a couple of options, A and B, could be C, could be D, and maybe you say, okay, I'll go with C. But one of the key topics that we do in the course is that to define the architecture of a system, you need to understand what the functional requirements of the systems are, but also what the non-functional. And people used to call them non-functional. Nowadays, the term that is more commonly used is quality attribute requirements. And so the question then becomes, okay, what are the quality attribute requirements? So for example, if in addition to the functional requirement of you need to be able to store 5 tons of grain, I ask you that the grain is to be accessible by waterways, then immediately you can see that C is the more adequate solution to the problem, because you have a canal or a river right here. On the other hand, if I say that one of the most important quality attribute requirements is scalability, so being able to extend the amount of grain that is stored, the capacity, let's say, of the storage, then you can immediately see that extending a building made of bricks is very hard. I mean, it's not impossible, but it requires a lot of re-architecting and refactoring. On the other hand, if you have steel silos, you can easily add an additional one with minimum effort. It doesn't mean it's free. You still need to go and procure it, and you need to place it, but it's a lot more, the solution D is much more extendable and scalable than all the others. So, one of the key learning in the course is that there isn't such thing as a best architecture, or there's a good architecture. What does good means? means one, fit for purpose, but also fit to context. We talked about quality attribute requirements. There is a lot more. For example, maybe the organization has decided to go with a particular cloud provider. So the solution needs to fit to the organizational context as well as the functional and non-functional requirements. So that's one of the things that we learn in the course, which is how do you come out with an architecture which is fit for functional purpose, fit for quality purpose, but also fit to the context as well. And what does that mean? And these are the things that really influence the architecture of a system. There are some influencing factors which are product related. I already mentioned functional and quality. Quality is really important. This is one of the reasons why iSAQB is perhaps, for me, is my favorite architecture certification, because in my experience, the most common failure of a software project is actually neglecting some of the quality requirements. I don't know if you've seen it, I've seen many times in my career, and at the beginning I was kind of, afraid of challenging that. But you see a lot of product where it says, the system should be scalable, the system should be secure. What does that mean? And then the project fails because, security and scalability weren't properly defined. But there is other influencing factor that influence the architecture, organizational factors. In the training course, we'll talk about Conway's law, for example, and technological factor. I mentioned already, for example, you as an organization already bound to use a tech stack, for example, then that becomes a constraint for you, and that also has an impact on the architecture, obviously. The key point is our job as architect is to understand what are the quality requirements that have a significant impact on the architecture, and we need to try and elicit them. And even when that is not possible, because it's not always possible, then we need to make some reasonable and explicit assumptions of what those requirements are. Right, so I used to, I like to use this example. When I talk about quality of systems and the fact that thinking about quality ahead, it pays off. So this is a library which at the time was the tallest library in the United States, opened in 1973. At the time was considered to be really a leading library. Great user experience for the readers that came into the building to read a book or borrow a book. Fantastic. But then eventually, only a few months later, actually, they realized that the bricks in the outside started to chip, and eventually some of them started falling. Is an issue which in the industry is called as referred to the term spalling. And basically, they didn't think in the architecting and design stage that the building was going to host 60,000 books, which was a significant weight on the building. So it sounds crazy now, but this is a real example. And obviously the cost of fixing it was substantial. Eventually it was reopened, but it's a great cost. And embarrassment. So, that's an example of thinking about the non-functional aspect of things is really, really important. And often they do determine the success or failure of a project or of a system. And that's where iSAQB focuses on. iSAQB's philosophy promotes an approach to architecture which is centered on the understanding, prioritization, and satisfying of quality attributes. Okay, quality attributes have a significant impact, in fact, disproportionate compared to the functional needs, a significant impact on the architecture of the system. And in fact, what I would argue is that in the day-to-day work of software architects, thinking about quality attribute requirements, both the elicitation and then how the architecture needs to address them, actually is the thing that will take most of your time. So that's iSAQB, if you like, distinguishing factor in my view, what makes it more actionable compared to other certifications like TOGAF, which is very much a framework-centric certification. In the training itself, to talk about, when we talk about quality attribute, we use as a as a model the ISO 25010 2023, the version 2023 of the which is a software product quality model. It has 9 broad quality characteristics. You can see them here: security, reliability, compatibility, safety, and these are then subdivided in, I think it's 41 more granular sub-characteristics that you see on the right-hand side. This is just a model. If you, for example, if you do a project with users AWS cloud, they have also a quality model as well. There is other models out there. So this is not intended to be the universal and complete and exhaustive set of quality attributes for a software system. It's a great starting point. It's a great checklist for you to say, have I thought about fault tolerance? Is fault tolerance a concern for this system? And if it is, have I thought about it, and does my architecture support it? But it's great checklist, as I was saying, but it's not the complete set. In fact, one of the things that I talk when I do the full training course, pardon me, is what other attributes could be, would we want to add to the system? For example, if our system had AI, machine learning capabilities. So one of the problems with AI, and in particular deep neural network, is that sometimes the output of the network is not explainable. Or even worse, could be unfair, and you wouldn't be able to explain why it's unfair or unethical. So I can imagine that for systems that have AI and machine learning capabilities, I would want to add some quality attributes in the space of fairness, ethics, and so on, and explainability, as I said, and so on and so forth. But of course, if you just discuss these attributes at this high level, kind of fluffy way, then it's going to be really hard to see how it's still useful, but hard to see how they will impact in the architecture. One of the things that we cover in the course is, okay, how do we go to the next level of detail, the next level of granularity? So we learn in the course to develop what we call quality trees or concrete quality scenarios, okay? So we go to the level of detail where we clarify some sort of measure for that quality attribute, some sort of priority level, okay? And also, when we talk about the measure, we include not only the measure for that quality attribute for the initial version. We won't have time in this course, but I talk about the minimum viable architecture. So we talk about what the quality attribute requirements should be for the minimum viable architecture, which supports the minimum viable product, but also thinking ahead how that requirement will evolve over time. So for example, I might want to say that when I go live with my minimum viable product, I want to be able to support up to 1,000 concurrently logged in users. That's my minimum viable architecture. However, I expect the number of users to double every week. That's my best growth scenario in the next 24 months. So immediately, this has the potential to shape my architecture in a certain way, because if I want that number to grow, then I know that I want an architecture that scales horizontally, for example, or vertically. But the point is, by going to this level of detail, then it kind of forces you to think about the architecture for day one, but also how it should evolve over time. Similar thing with response time. So you say, initially, I'm happy that all the requests, 80% of requests over a 1 hour period are satisfied in less than 500 milliseconds. But I know that for this product to be successful in the long term, I need to be able to reduce it to under 100 milliseconds in the next 12 months. So this information really, and how the relative prioritization of this quality attribute requirement is really, really important for architects to sometimes lead the elicitation of these concrete quality scenarios, because they can have a really significant impact on the architecture that you then choose. And in the training course, we learn how to do this. So that's the first bucket about some of the concepts that we cover in the training course. The second bucket is about key approaches. And the key thing here is there's many ways that you can go about doing architecture: top-down, intentional, bottom-up, view-based architecture. This is the historical one that's, was the most common, let's say, in the 80s and 90s. More modern ones like domain-driven design, agile, which is a combination of iterative and incremental, model-driven architecture, MDA, evolutionary. I mentioned about this. I mean, for me, evolutionary architecture is really, really important. And the other one that I talk about is decision-centric architecting, which is also is not here, but it's a way of doing architecture which is really a surface over the past, I would say, 4 or 5 years. But there's others as well, like the TOGAF architecture development method, hexagonal architecture. There is something which has really surfaced over the past 18 months, which is a new approach, which has been labeled residuality architecture. So there's many, many ways, but the key learning point for today, at least, is that, people say this is the way we do architecture, it's actually short-sighted, I think, because you at different stages in the project, depending on the nature of the problem that you're trying to solve, you are likely to have to dip in and use several of these different approaches to architecting. And in fact, one of the key learning points is you need to find the balance. For example, one of the key decisions that you need to make as an architect is how much effort do I invest in the upfront design versus the acceptance that the architecture will itself evolve and emerge over time as well. So this is better if they are explicit decisions rather than just happen accidentally. And that's, what we do in the training course is look at all these things. These are some of the examples of the common architecting approaches. As I said, top-down, which is the attribute-driven design, view-based architecture. We learn the famous 4+1 views by Philippe Cruchen. Hofmeister, it was one of the people that come out with another view-based model. We also talk about briefly how we use AI to help us with our architecting approaches. Decision-centric, already mentioned. I think this is some of the things that is actually becoming more prominent over the past couple of years, and it's really the central artifact, if you like, of architecting becomes the architecture decision record. And for that to work, and for that to kind of, for decisions to happen in a way that doesn't slow down projects, you need to be able to plan the decision that needs to be made, who needs to make them, and then you make those decisions, you document the decision in architectural decision record, and then some of them, the most significant ones, you validate them. And evolutionary, it can't really be even described briefly in a couple of minutes, but it's one of those that we also cover in the training course. So there is many approaches to architecting, and you need to pick and choose. And in the course, we actually go through many of them. So it's sort of you can think of it as a toolkit that then you kind of open and pick the right tool when you need to define some specific aspects of the architecture. So that was the second bucket. That takes us to the third bucket. I'm going to talk a little bit about iSAQB and the curriculum. So iSAQB itself, I think I mentioned this at the beginning, you can think about it as the sister organization to the iSTQB, which is the International Software Testing Qualification Board, founded in 2008. I think most of the presence of the iSAQB today, is fair to say, is in Central Europe, and then Asia, and now is making inroads into the UK and the US as well. So there is a standardized curriculum. I think one of the key things is that it's not purely about technology, it's not purely about methodology. It needs to include some aspects of both, but also considers a very important the soft skill side of doing architecture. So, it's pointless to have the best architecture perfectly documented if you can't communicate it effectively to your stakeholders. Okay, and the other thing is obviously there's quality control on the examination. The examination is for the foundation level anyway. It's a multiple choice exam, which is administered independently by independent organizations. So you buy a voucher, you take the exam either online or in a location near you. The advanced level, you pick and choose. You need to cover at least some of the three competences: methodical, technical, and communicative competence. So you need to cover at least some of them. And you have a sort of menu of things that you can learn from agile architecting, that's a methodical competence, to cloud infrastructure, that's a technical competence, and soft, which is a communicative competence. So you choose a number of them, you gather some credits, and then that takes you to apply for the advanced level certification. The training that you'll see as if you like, sister to this lightning session, is the foundation level. Okay, so the topics that I covered today and the 3 days course that you can purchase from Architectural Thinking is on the foundation level. Okay. And these are in more details what are the actual topics, the learning outcomes that are covered. The course starts with, key concept and key terms, what are the benefits, tasks and responsibility of the software architect, architecture domain, data, technical, business domain, and application architecture, and so on and so forth. Then the bulk of the training course is in here, which is about identifying the qualities of the software system to a level of detail which is sufficient to be able to inform the architecture. And then it talks about architecture principles. We cover what are the key architecture principles. We talk about solid principles, for example, but also architectural styles, monolith versus distributed, data pipelines, and so on and so forth. Design patterns and architectural tactics. And then we talk about, which I think is one of the most important topics in architecture, which is coupling and cohesion. So that's about doing the architecture, forming the architecture, as I say. Then there is a block on how do we document and communicate the architecture? What are the key models, the key notation, how we document architectural decisions, for example, and communicate them both in a written but also in a verbal way. Verbal communication is often, I'm not going to say neglected, but is not considered as important by many architects, unfortunately, because it's more difficult, I think, to really condense a lot of information into a conversation. But it's really, really important and critical to the success as an architect. Then we also see templates for documenting architecture, tools for documenting architecture. We talk briefly about diagrams as code, for example, and some of the best practices in documenting architecture. And then the final block is about how do we evaluate how good an architecture is, how fit for purpose and fit to context it is. We go through some analysis and evaluation methods, both to evaluate quantitatively and qualitatively the architecture. And then we briefly talk about governance and conformance. And all this kind of supported by real-world examples and by hands-on activities. The full curriculum, you can find it on the public iSAQB website. And if you have any questions on the curriculum or on anything else, really, then please feel free to drop me an email. So that's the iSAQB. I did say at the beginning I will talk a little bit about how does it relate to other architecture certifications. Okay, so broadly speaking, I would suggest that you need to think, if you want to achieve an architecture certification, broadly speaking, you need to think of two dimensions. One is clouds or vendor-specific certification. So, for example, if your organization uses AWS, AWS has a solution architect certification that you can get, and similar for Azure and similar for Google. So, it's really important that you know the ins and outs of the technology that you're using. iSAQB alongside TOGAF and the one by the British Computing Society, they are more vendor agnostic. So they prove that you understand to some degree architecture as a discipline. Okay, they are platform agnostic. I think that what differentiates, for example, iSAQB from TOGAF is very framework centric and really is 800 pages of frameworky stuff. And maybe you will be able to use 10, 20% of it in your organization. And it's really aimed at enterprise architect primarily. I think iSAQB is more ready to use. You'll be able to use out of the box 80+% of what you learn. It includes methodological stuff, but also technology and communicative or soft skills. Okay, and it, if you like, is less for enterprise architect and more for software project architects or solution architects. So that's the kind of how they differentiate from each other. Right, I think we're a little bit out of time. A few takeaways. In fact, 4 takeaways. The first one is there isn't such thing as a best architecture that is guaranteed to be successful. What you need to do is understand what the quality attribute characteristics are, because that will have a disproportionate impact on the architecture that you will choose for your system. Think of architecture as a decisioning factory. Okay, so you need to balance upfront design, but also accept that architecture will evolve, just like most products do, over the lifetime of the system or the product that you're developing. But think about, this is a more modern way of thinking for architecting, which is, what is the set of decisions, the architectural decisions that need to be made, and how do we balance upfront intentional architecture versus the evolution of the architecture over the lifetime of the system. The third one is quality trees. You need explicit, concrete, and evolutionary quality scenarios. Okay, and we use the example, the quality trees, with priorities, measures, but also the evolutionary scenario. So when you say 1,000 users from day one, but I need to be able to grow that. That's a growth scenario. There's other types of scenarios that we learn in the training course. And we haven't even touched on, I have another training course which is on how does AI impact and how does it augment the role of the architect. I think one of the most important thing is that a lot of the design decisions are made explicitly by humans rather than by machines. But I think the key takeaways, so we're not going to have time to cover that today. That's a whole separate training course. But the key message here is that the role of the architect is changing. And I love this quote. And in fact, the role of the engineer is changing as well. In fact, the engineers need to become more architects than coders. But we leave that for today. But the key learning, the key takeaway is that, it's not the strongest that survives or the fittest or the most intelligent, is the one that is the most adaptable to change. And the discipline of software architecting and software engineering as a whole is changing a lot. And so you need to be on top of that. And, this is one way, this training course, to help you do that. Right, so that's where we are. Thank you very much. You can find the curriculum for the training courses that I have live at the moment. As I said, the iSAQB Certified Professional Software Architect. The training course is a 3 full day, which I actually deliver as 6 half-day training course. You can, if you're listening to this session, you can actually use a promo code, but even better, for only a couple of days, there is a 50% discount code that is live as well, and it's iSAQB Maven Launch. So if you book the training course through Maven, you can get only for a few days a 50% discount code. If you have any questions, please reach out, contact me. Otherwise, thank you very much, and have a good day wherever you are.